I can do the intro. Okay. Good morning, everybody. It's the 1st of May, 2026. This is Brad DeForge. We're going to start today's, what are we called now? AI, wireless AI meeting, the evolution of Evenstar. And here we go. Morning, everybody.
Good morning. So do we have any agenda items that other folks might want to add? Hisham and I were talking earlier about some emails that Hisham sent. Do you want to talk about that, Hisham?
We could also do that as well as Canada Tech Day. We can probably talk
Should
about
mention that as well. Yep.
Yeah, I think the gist of this email is that people have doubts now about using GPUs in the RAN. Like Orange, for example, is saying, why we do that? We can still use CPUs. So this whole business case about having NVIDIA technology in the RAN is questionable by operators. So I
Yeah, we
agree
were
with,
talking about that
yeah,
earlier.
yeah,
I
I
think
agree
there
with,
needs to be some costs sort of ROI analysis done on this. I mean,
I
yeah, I
agree
agree. Yeah,
100%. Like Orange cannot establish the business case behind it. And I'm sure
exactly. And I
other
think
operators may have the same issue.
if any of the folks here have been involved in the AI RAN effort that's going on. It's related to the OCUDU effort that's out there. And in fact, the couple of meetings that they've had last year, I don't think there's been one this year. That's come up too, Hisham,
Yeah,
where the whole organization struggles with. I mean, there's like a lot of ideation, but then when it comes down to where does the rubber meet the road, that's where we get tricky.
yeah,
I mean, there are efforts, around using the Arc Pro, right, from NVIDIA, with the L4 to do some of the RAN functions. So I know that a bunch of the carriers have done experiments with it and have proof of concept and pilots. So obviously Nokia is doing it. KDDI has some efforts around this. SoftBank is a lot more aggressive about this. T-Mobile has some experiments around it with NVIDIA and Nokia. So the experiments are ongoing. No one has come out right and said that it's feasible in large scale, but there are pilots and experiments running, and Nokia is committed to using GPU platforms in their RUs, in the near future. Although, it's not going to be a B300 or B200 or even H100. Likely, it's going to be the lower end versions that take less energy with less compute. So there are efforts. It's ongoing, but no one's saying that they're ready for production yet. Nowhere near production.
exactly,
Yeah.
exactly.
Yeah, the
So
power is another good point too, Hisham. Like, I don't know if that was in your note too, but that's another concern. Um, besides trying to use the world's most expensive hardware right now for those use cases, the other is simply power. Like a lot of RAN, B sites are already like at the limit for power that they have available. So that's another consideration for sure.
I mean, the one question we can go back and ask someone like maybe Marvell that is a bit more neutral. But obviously NVIDIA put money into Marvell too, right? So,
Mm.
but that may make them more neutral in terms of investigating the probability of a hybrid type silicon that has some kind of GPU functions,
Yep.
but
Yeah,
still has
that's
the energy efficiency, right, for the RAN, and that may be worth taking a look at. But I know that some like Verizon, Yago is saying it's definitely not anytime soon, which makes sense. I think AT&T is more neutral about it,
they're
right?
severely
Rob's,
cost constrained. If
yep.
seen what they're trying. You know, the new CEO is up to
Yeah.
over there, and
Yep. Yep. So
yeah,
Verizon has, yeah, I mean, Dan Schulman's cutting people and AT&T, and then T-Mobile's the only one that's making noise. But even if you ask T-Mobile, they're very, very
yeah,
careful. They're
yeah.
not saying it's ready. They're just running experiments and pilots. So, um, yeah.
But that's a great point, Roy. That like we're working with a bunch of the up and coming GPU vendors that are out there. And there are some wicked low power options out there and very low cost. The question
Mhm.
is, will they work enough for what folks are trying to get them to do, even,
Do
at
we
these,
do we
you
have
know,
an idea of what people are trying to do? I mean, how many watts is enough, or too much rather? And what are people trying to do? I mean, the NVIDIA's Jetson Nano is down to 5 watts. Um, I don't know
yeah, but
exactly
it's
what the
also
performance is.
$1,500 for the machine. So plus one, minus one,
No,
right?
but why they need low power? Why they need low power? I mean, the low power in the ORAN station is not a very like attractive because, I mean, ORAN already draw a lot of current and a lot of watt. So why
Oh, no,
low
no,
power?
I don't think it's necessarily low power. It's you can't use more power than the RAN has today, is what my point was.
Oh yeah, sure, sure,
That's
sure.
that's really it. Like, so you have to replace what's there somehow.
Okay,
Uh,
yeah, sure.
is
I mean,
is is those cases, I think. But then what Roy was saying, like, there's a lot of operators today who are like, hold on, I can't spend another dime out there. you know?
why they cannot spend more money?
The today's ASICs are optimized, power efficiency, compute efficiency, and price efficiency because of the volumes of number of
Hmm.
RUs they're putting out, the number of, and so you have to be able to beat that. And I think the
Yep.
argument may be, well, you shouldn't be just looking at that. You need to look at the TCO. Okay, if you look at the TCO, OpEx and CapEx, then you have to look at the whole stack, right? Is the OU, the
Yep.
CU, the RU, plus the OpEx on top of that, plus what else you can get out of it. Because sometimes we use as an excuse to say, oh, look, the TCO is this, but look, the ROI is higher because you can use it for sensing.
Mm,
Wouldn't
Yep.
it be great if you could detect drones and protect the nation with it, and therefore the ROI equation is different. What's the cost of a life, right? I mean,
mm.
Right. So that's the point I was
yeah.
making, Roy, is that I was trying to get it back to the TCO conversation that Brad started last year.
So the TCU is the tensors unit, or what is
No,
TCU?
no, total cost of ownership.
Total
Sorry,
cost of
Oh,
total.
total
ownership.
cost of
Yeah.
Well,
okay,
Yeah,
I
the whole
get it.
math, and that was the point of reforming this group, in fact,
well,
was to
Yeah.
to step back and consider all of that stuff
Sure, sure.
before.
if we could go back a second to, you said ASICs. ASICs are inappropriate for the use case we're talking about because they're not modifiable after deployment. They're not
Mm,
programmable. You would want to have an FPGA, like the Xilinx device or the um, Marvell.
Yeah, the Marvell.
Well, no, I was
Marvel.
thinking Intel, whatever the Altera device. I
Mhm.
mean, those devices
Oh,
at their core still have um, quad 64-bit ARM cores in them, in addition to
mm,
the FPGA, in addition to ASIC logic for running the radio front end.
Mhm.
Um, that's a hell of a lot of horsepower that can be put into um, AI algorithms once you decide what those algorithms are. But
Mhm.
you can't go to a hardwired ASIC if you're going to want to have programmable algorithms.
Well,
Mhm.
I think it depends on what your ASIC is, right? I mean, or how you define an ASIC, because the ASIC can have multiple ARM cores built in. The ASIC can have matrix multiplier units built in. This you have to decide the level of programmability and the
Yeah,
level of hard
yeah,
coded. Yeah, that's the mix.
absolutely. That's my
Yeah,
point. So
yeah,
what I'm
that's
getting
correct.
at
Yeah,
is that you already have extraordinarily powerful programmable devices. Why are we looking for something new?
because
So
it's cool. No, no, no. I
yeah,
mean,
that's
I
well,
mean,
I
but
think
that's
that's the
that's just
point
a
Hisham was making, right? Is like,
Mhm.
why are we doing this?
No, I
I
no,
mean
think you're
it
just
sounds like
asking
this
the
is a
honest
software
question.
definable task, is what I'm saying. Is not doesn't require new hardware. It simply requires a
Yep.
new approach to coding and being able to put um,
Yep.
high performance algorithms in the programmable FPGA, which typically not a lot is running on that at the moment, um,
Mm,
because you do have the ASIC analog front ends. I mean,
And
No, but guys, just wait a minute, please. Wait a minute. I mean, when we say ASIC, we don't define what is inside the ASIC. And back to Hisham question, either a CPU or GPU. Okay,
No, it's an
let's not jump.
FPGA because the GPA.
Let's no CPU versus GPU. Okay, let's not jump the gun here. Just
it-
step by step. Okay, CPU is not computationally capable. I know there is just hype, like Intel recently reported a report. Okay, there is a demand for the CPU. Okay, great. But I mean, if you run a machine learning algorithm or deep learning algorithm, okay, if you run this by your hand, really, you would also know what I'm talking about. These are computationally extensive algorithms. You cannot run them on CPUs. So if you have a machine learning algorithm running to control the radio unit or control the DU, CPU will be computationally constrained. So you have to go to hardware that is have a lot of compute power. And this is the closest thing is right now is the general purpose GPU. So I mean, I don't really
yeah,
think
Well,
Hisham.
so,
but the programmable logic in an FPGA based RU, where you have your primary four quad cores, 4 cores of 64 bits each, at very high end NVIDIA, ARM architecture. You've got a lot of compute power there for
yeah.
running general purpose
Yeah,
compute.
they are hybrid device. I mean, the reality is it's a hybrid device. Whatever we're
Yeah.
going to end up with is a hybrid device. The allocation of
Yes.
the silicon to the different components that make up a hybrid device, that's in process and not clear. And I'll tell you what I learned from Samsung, right, at MWC, which is they said, look, they're running on Intel with the VRAD, right? And DUs have L1 acceleration with Sapphire Rapids and Granite Rapids. And what they're saying is, look, we can run 64 TR, with Intel, no problem. But on top of that, we can run it with AMD as well. With multiple cores, we can achieve 64 TR as well with AMD. And by the way, we're running experiments with GPU. So what they're saying, at least what I heard was, it's feasible even with CPUs. By the way, CPUs are no longer CPUs. They have vector operations, acceleration, and obviously in the Intel case, they have L1 acceleration as well, right? For DU use cases. So I think maybe, I don't know how you approach it, but the question here is, for the use cases for what we're trying to do with autonomous RU, I think the question is, what kind of compute operations are we trying to look for? How many total flops or ops
Yes,
are we looking for?
exactly.
How do we
These
achieve those flops, ops, memory,
are the
and then go
methods
out
we
there,
use.
right? And try to
Yes,
figure out what's available to us.
And
Yeah,
and
yes.
just not just CPU, because again,
exactly.
FPGA
Yeah,
logic can be programmed for
yeah,
compute intensive
exactly.
algorithms.
Exactly. But
So
the only
look,
caveat is FPGAs. I just want to say, I think for the purposes of exploring, it makes a lot of sense. The only thing is, remember that FPGAs is a path that Nokia went down. When they did the radios with 5G, that path failed and they had to go back to Marvell for assistance with ASIC. So it was a
Well,
power problem at that point in time, right?
FPGA in this time and this era includes ASICs for high performance DSP algorithms, programmable logic for new functions and features, plus multi-core high performance
Yep.
ARM CPUs,
Yep.
which have been used in RUs and deployments.
Yes. Yep.
And
so James,
Fujitsu's entire product line is based on an
Yeah.
FPGA.
yeah, James, I wouldn't be very careful there. I am from the FPGA industry as well, and I do believe FPGA has a big space in that game. But FPGA in general is a general purpose architecture. You cannot win on all front. I mean, if it's a general purpose FPGA, it cannot be the best performer when it comes to computational extensive task,
It, it,
even
it,
though it has multiple core, etc., etc.
it's the best performer for programmable uses, which is what you're trying to do here.
Well,
Yeah. I
well,
mean,
correct.
if we're
Look,
experimenting and trying to figure
what
out, I agree.
we
That makes
try.
sense.
Again, what we try to do is different from what we are trying to answer Hisham question. Okay, our project, yes, it's an early phase. I think we are still in research phase. We try whatever is available and whatever fund is we are able to attract to support the project. But but we are discussing Hisham question: is it the CPU or GPU? In my opinion, this is a hype. It's not. It's not scientific to use CPU for AI because demand for compute is very high. CPU
Yeah,
cannot be used. So
I would posit it that we're not just talking about CPUs or GPUs because there's more classes of architectures out there than that these days.
yes,
Yeah.
yes.
Yeah, I
Yeah. If
agree.
we
Well,
could just
I
go
agree.
back,
yeah,
what
sure.
functions are we trying to perform, right? I think maybe just step back and say, what functions are we trying to perform? At what rate, at what efficiency? If we can just understand that, then we can map it to whatever we want. And if we don't know and we need to experiment, then we can pick the platform for experimentation that makes sense. And very often it could be an FPGA because that's what you start with. I mean, a lot of the AI silicon starts with giant FPGAs, put together, running at a lower clock speed for the time being, while they try to do cycle accurate simulations of that. Makes perfect sense, right? In the early days. Once you figure it out, then you can lock it in if you know what you want, right?
Well, that's the problem is AI is evolving so quickly, you're never going to know what it is.
So,
Yeah.
I agree with Roy and James on this one. I think that certainly the programmability going forward for the next few years. I mean, let's back up and look at the world from a year ago. A year ago, everybody was thinking, oh, well, look, the RAN runs on bare metal. We have Intel-based servers running everything from custom RAN to whatever feature you might want, and then suddenly things changed. And we still have the capability, as Roy was saying, to run 64TR on Intel. We have FlexRAN on Intel. We have inline accelerators from various other companies, usually based on Marvell. But if we're going to look at this from an extensibility perspective, because we don't know, because we're in the architectural phase, and because we're only 1 year into this journey of, hey, why not put GPUs down at the bottom of the RAN? Then perhaps what we should be looking at is what is the flexibility of the server itself and what expansion, what PCIe ports does that server have? And we could throw in any GPU we want. You could put in an L4 from our friends at NVIDIA or somehow pack a GB10 in there. All of these things could be possible. And need the experimentation. We need to go down this path and actually do exactly what Roy's saying. We need to define what are the new use cases. From a year ago, you had bare metal running on Intel. Today, you have these proposed ideas of parallelization of the L1 that NVIDIA is talking about on the aerial arc. And you also have the sensing idea. And the sensing idea is very much a DU kind of RU-DU collaborative workload, which will use AI. But is it the killer app that we're going to want to have a wholesale change in the architecture for? Is that going to be the one thing that tips us over? If we look at ITU IMT 2030, ISAC is certainly on there. It's one of the 6 pillars, along with ubiquitous communications. So do we need to look at both NTN and terrestrial communications combined into a single node with ISAC baked on top of it? And in that case, now we're getting into use cases that I kind of hazard to guess that none of us have actually sat down and sketched out on a whiteboard yet.
So I think also it's based on the use case. I mean, the use of the hardware is based. So, for example, if you are using large language model, definitely you cannot use FPGAs or even Intel. You have to go with NVIDIA GPU. If you are using edge, like some edge AI use cases, where the AI is located near the sensor, near the source, yes, you can use FPGA definitely. And I think Intel CPU will be expensive for such use case too, so it's not suitable. So it depends on the scenario and the AI. Like there's different use case, different scenario. Not a single solution can fit all.
And I think we don't have to define a single solution. I think we have to define at least an initial pilot architecture that allows the flexibility to plug in what we need to be able to plug in to run the possible expenses.
Trials and experiments.
Yeah,
yes,
exactly.
Yeah, we need
Yeah,
a
yeah.
framework around.
I'm not saying define a single solution. No, I'm saying the opposite. I'm saying there can be multiple solutions, but in our case, I mean, in L1 or the radio or the RAN, I mean, there is different layer of the RAN stack. Maybe in some layer, maybe the FPGA is more appropriate choice. Maybe at the higher layer, application layer or control layer or traffic, maybe GPU is more appropriate choice. So even in the RAN scenario, there can be multiple use cases. Each one will need different hardware.
So the
Right.
So
question
a question to James and Hossam is it possible that a PCI expansion slot at the server, the DU, is what you need to start with? Would
No,
that give
not
you the flexibility?
necessarily. I mean, the global market share for Open RAN radio units is owned by AMD with their RF SoC chipset line, their Xilinx products. And Marvell plays a role in the market, but they're way behind AMD. And then Altera is with the former Intel RF SoC group. Yeah, I believe that the term I was been using, the FPGA, is a misnomer. I should have said SoC, or specifically RF SoC,
hmm
where all the radio
hmm
function
Yep.
is ASIC,
RF
and then
SOC,
it's
RF SOC.
yeah, RF
That's
SOC is it's the, for example, take a look at the website for the Zynq ZYNQ Ultrascale Plus. It's the single most popular radio unit SoC out there.
yes. But I think
hmm
at the beginning of this AI native, we talked about Dell, guys. Remember? I remember you said Dell has a radio unit or a new innovation in the radio unit, and that was like originally where we landed on the radio unit, right?
In Evenstar.
Yeah, in
Yeah,
Evenstar. Yeah.
that was the Xilinx part, but it's also the part that Mavenir uses, and
hmm
Dell is a fan of Marvell, but that's just Dell, and Dell is not very big in the telco space these days.
Okay. Yeah. Okay.
Oh,
And I know that
can I zoom this out a little bit to be constructive? Like one of the things I think we need to do here is enumerate just a couple of cases where we think, that's the use case for this. So, and then spec it out. Let's write this down.
you're talking
And
something
then,
like ISAC.
well, like let's take the use case and go front to back and see if, Hassam's assertion that it's not going to cost in is something very interesting to prove, right? With sort
Yeah.
of like the conjecture is that we're driving down the road with our hands over our eyes, just going la la la, everything at NVIDIA is okay now. And his conjecture is that that's not the case, and it's not going to cost in when you get to the end of the road. So it'd be instructional for us to just, to take, maybe a week or two, see if we can enumerate this stuff. I think this would be helpful too for um, the AI RAN organization's efforts too, is some
hmm
sort of input over there. We're collaborating with them, so that's part of what we're supposed to do. And then the OCUDU effort is very related to what we're talking about as well. So maybe that's what we can do to be constructive, to try to move the conversation forward. I think the goal here is to find out, like how is this actually going to stack up? You know,
Yeah, I think the
what do
goal,
you?
the goal of, because we're under OCP, the goal ultimately is some kind of reference architecture from a hardware spec perspective that can
Yep.
support all the necessary hardware components that go into a next generation RU that fits within the Open RAN architecture that collaborates with, OCUDU, right, OCUDU, and that somehow integrates with the AI RAN Alliance's sort of vision or template or framework, right? I think because
Mhm.
our job is hardware, so at
Right,
least
right.
on that, right? So if we said that that's the goal, then we work backwards and say, for that to happen, even if we know it's not the final hardware, what steps do we have to take? What experiments do we have to do? What
Yeah,
pilots?
it's a
Right?
reasonable
Uh,
it's a reasonable facsimile of what those things would be anyway.
Yep.
I think
yeah,
everybody here works on this
and
stuff.
we have to decide how much of this is on a homogeneous architecture or is it a heterogeneous architecture where some
hmm
functions span from programmable logic to software and do that in a
Yep.
way that can be containerized and scalable.
Hmm.
Yep.
So I mean 2 point. I mean, it's okay to think about it and give the imagination and creativity of each team member to think about it. Another way to approach it is not to reinvent the wheel. Okay, use whatever exists in the market, whether from AMD, whether from at Lattice. Also, we have an AGI scenario with, and we work closely with NVIDIA on that. And in don't reinvent the wheel. Use whatever
No, no, that's a
company
great
offers,
idea. Yeah,
and,
we
and
don't
and
need
just
more
build on top of it,
ideation.
because we
You're
have
right.
spent a lot of hours in researching this, guys, and
Hmm.
looking at this, and I'm sure you don't want to reinvent the wheel.
No, like
So
the AI RAN Alliance has, they have a whole stack of these use cases. You're right.
yeah,
We don't really need more ideas in that regard. We need to prove that any one of those might work right.
so use even if you can bring the AMD, that's great. At Lattice, we have that AGI board and
Hmm.
work with NVIDIA. It's better to build on top of that because this is a proven use case from commercial even point of view that will bring a fund and money to our project. So that's why
Yeah,
I'm saying, yeah, try
yeah.
to build on existing solution that exists.
So that's what I was actually suggesting is that we try to we pick two or three of those use cases and
Yeah,
go through them and see if they will work with what's
yeah.
available.
Honestly, I'm happy with. Honestly, not because I'm from Lattice, but I'm happy with what we have at Lattice in the AGI because the scenario here is we enable sensors, all sensors connected
Yeah.
wirelessly through the 5G, whether it's a temperature sensor, humidity sensor, camera sensor, surveillance
Mhm.
sensor, etc. that connect. This is a use case of a AGI where you can use a FPGA.
So
And
that could be part of the actual, the ROI justification or
yes,
the TCO.
exactly.
Sorry, not ROI, but the
Exactly.
TCO
And this idea
math.
has been vetted commercially. As I said, I mean,
Yeah.
it's commercially viable. So we don't want to go to a path that we search for an idea, but it doesn't make commercial sense or so. So don't
Hmm.
reinvent the wheel. I'm saying.
No, so Brad, what are you thinking here? Brad too.
I'm thinking,
Brad
yeah,
wasn't here. One
Brad,
isn't here.
Brad one, yeah, had to not make it. No, I agree that we need to identify the use cases. I think we need to start um, building I guess start with a use case and use that as a straw man and say, okay, what do we need for this? And then
Yes.
also we need to look at how would that use case be distributed across the RU and the next layer up, so the DU level.
Yeah.
Um, and it may be the case that it's a hybrid, but not exactly in the same way that was just mentioned, but more of a hybrid between different layers in the network. If the RU does some acceleration and compression of the data that's being collected, so that the front haul isn't so burdened by that weight, maybe there's a way to put some um, less power hungry components into a radio, not break the bank, and then put a little bit more power hungry, more capable components at the DU level.
Yeah. Yeah. So
And then, I
that
mean,
sounds like a
I'm thinking also of the industrial use case. If
yeah.
you're going to want to have relatively small, pico cells or whatever you're using at the machine level, at the robot level.
Hmm.
You don't have a budget like you would in a macro radio to put in $150 or $300 worth of components, let alone $1,500. But in
Yeah.
the server room, you might be able to put a much more capable processor in there.
And there's a middle ground between those 2 points. Like in my industrial cases I've talked to, the big four guys, the usuals, they're okay with a AP sized
Yeah.
box, to do this stuff that then, 20 robots would be tethered to. Um, Sort of like scattering access points across, a floor of an enterprise. So that's another thing to think about too, is they don't have to necessarily be picocells. They could just be, access point size cells
Mhm.
to cover, a, whatever, 300 square feet or whatever we want to use as a model. But in between thing, and that's also another vector for that will change the variables too. By the way, around power and cost, right? It's the math there is different than RAM. Um, the math there is a little bit of both what you find in RAM and enterprise, which is kind of weird. Um,
So
so it depends.
yeah. So one of the use cases that I love, guys, I mean, I study the 5G narrowband IoT a lot. I'm actually the author of 3 books about 5G narrowband IoT, so you can find them on the internet. But the use cases we use in narrowband IoT, of course, it's a two sides. So one side on the sensor side, where you have like AGI or pre-processing AI, and then this sensor send a lot of data to the cloud, and on the cloud, you can run heavy AI and machine learning algorithms. So you can
Hmm.
utilize the AI engine on both sides of the story, the device side or the ORAN side. And well, I mean, this sensor is essential in our daily life. So, for example, think about a smart utility, that utility meter in our home. It's now all all hooked up with a wireless sensor that send them meter reading to the cloud, and then it keeps processed in the cloud. What is the power consumption by zip code, by area? What is the peak? What is a peak hour where the consumption is very high or very low for emergency? And you can run a lot of AI algorithms on the cloud for these sensors. So so one aspect that I see in the 5G is that narrowband IoT, or whatever is known now as RedCap or reduced capability. This is a higher rate kind of sensor in the 5G, and mining all these data coming from the sensor is a big deal. And where is this AI or machine learning algorithm will be useful to mine into these data collected by these sensors. So this is one big use case that I'm coming from. Uh, and
I
that's what
think
we use in the on lattice AGI platform with NVIDIA, actually. So
I think we probably ought to consider some use cases that don't implying that the customer trusts the cloud service provider, because I think there's going to be a big pushback against AI when it starts invading your home. Why should I trust Google? Why should I trust Meta? Why should I trust Microsoft? Why
100%.
should I trust T-Mobile? Um, I mean,
well, it's not the operator who, I mean, the operator just provide the infrastructure. I think that,
yeah,
for
but
example, in the smart utility example, it will be managed by the utility company, the normal utility company in your neighborhood.
I
So
doubt that, because the utility company in my neighborhood is serving 500,000 customers total. That's hardly enough to make an AI business model.
that's enough or not enough? You are saying?
Is not enough. You need I mean, to offer services at scale, you're going to have millions of customers. And I think a lot of people are getting ahead of themselves with AI, because, you know, when you start having humanoid robots and self-driving cars on the road, there's going to be a lot of people out there wondering, why should we trust Musk?
Mm.
Well, I mean, this is another side of the story. I don't think we are. Okay, I don't want to argue too much about it because I don't think we are in this story yet. I mean,
Well,
I
this
think we are
isn't
a
the
group of
place
researchers,
to
right? We
kind of
are
have that argument. It's
a
it's like
group of
let's write that down
Let's write it.
scientific
Well,
and
in
research.
this analysis, right?
what I'm saying is we need to
Yes,
narrow the scope to something that is
Yeah.
clearly desirable in the near future so that we can have a target. And
Yes.
ISAC sounds like one of those things.
the
Yeah,
integrated
that's what
sensing.
I'm saying is let's pick like 2 or 3
Sure,
examples and
yeah,
and run
sure.
them down.
But you have to be specific. I mean, if you give ISAC like integrating sensing and communication, give a specific example. This is
Yeah, well, help
Yes.
physical
No,
AI in
no,
a
no.
factory, or
Yes.
drone sensing, or just pick a couple
yeah,
that have different
Yeah.
corners of performance requirements and go from there.
Yeah.
yeah.
The case Brad was just talking about with, a nanocell type, that in an industrial environment, and then a RAND case, that there's two from 2 different representative industries that, you know, anyway, the
So
feeling is that they will need this kind of something like this, and
yeah,
so
great.
that
But
be
again,
productive.
remember, ISAC is part of 6G standard. or part of the 5G advanced standard. It's just a new standard. It's not commercially available yet, and still, I mean, at current time, it's still more of research. There is no practical use of it. It's a great idea, of
It,
course. It's
it
something.
I would beg to differ. We have a worldwide critical requirement for drone sensing, and the requirement is going to increase over the next coming months and years because it's the future of war, and we've got war breaking out on all continents, basically.
Okay, but war is not a is not like a mass scenario, right? I mean, it's just. I mean,
Drone sensing is not, no, I mean, we've got drones in combat use in North
no.
Africa,
I
in the
don't
Middle East.
argue. I don't argue the use case. I'm saying in general, the war or drone is not a mass use.
So,
I
but
mean,
I think from a hardware again, let's go back to the OCP. We are part of OCP. We're defining a hardware architecture. The hardware architecture has to accommodate the processing of information, integrated sensing information, even as 6G specs are being worked out. So all we need to do is figure out what components are available now in the near future that we would like to accommodate within the hardware architecture. What part of the architecture do they fit in, and how do they fit in? I mean, that's basically it. Is it a PCIe bus? Is it an expansion unit? Is it whatever it is? What that actual unit is, we can look at what's available now and what's coming down the pike in the near term. We just have to accommodate it. And we can debate whether we need it or not need it, or how much of it we need. And that's okay. But again, we don't have to figure out all the answers. We just need to figure out, if people want to figure out the answers, what's a hardware platform they can use to do that? And can we define as OCP an open hardware platform that's multi-vendor, open standards, that can accommodate that kind of research and experimentation and eventually production, right? That's it. That's our role in the ecosystem.
Oh, and finding partners that actually want to prototype and productize it.
Build it. Yeah.
Yeah, we need
Yes.
we need that. We
And
need the money.
and
Yeah.
that's why I'm harping on the drone sensing, because Japan, Southeast Asia, the Philippines, China, India, countries all across the Middle East, countries in all across Europe are going to be wanting that.
Yep.
And for some of those countries, it's not a matter of, hey, it's desirable, it's existential threat.
So
well,
it's
I mean,
gonna
you
probably
can.
happen in one form or another then.
Yeah,
Yeah.
yeah. I mean, you can point us. I mean, to a solid example about this drone, James, so that we can study it, and yeah, we can discuss it next meeting. That's okay.
Hey, James, by the way, is that URL you pasted in the chat window? Does that actually work? I can't get there.
Yeah, because we do the chat window after after we finish the
It
meeting.
worked for me.
Maybe send it on an email.
Let me check it.
It's weird.
Where's the chat? There it is.
Yeah.
Yeah, I just looked at that. From,
Weird.
yeah, there's others like it. I was just looking at silicon vendors that are servicing or that are doing prototyping in the ISAC space.
Oh, it might just be me over
Well,
here.
I mean, do we have the infra? Do we have the tool and the infra? I mean, usually I like drone. I like drone myself, and I find it's a very. But usually the tools that is always required in experimenting with is difficult. You need to find a drone. You need to fly it sometime. You need to have some security clearance. So it's a little bit. I mean, there is some regularity.
Where are you based? Where are you based?
I am in the US, but to fly it outside the US
No,
sometimes.
where are you based?
Where I'm based, I'm Seattle. I'm in Seattle.
Okay. So there's half a dozen states in the US have drone testing grounds. Texas has one of the largest with, I think, 500,000 acres. So it's not that hard once you have something to fly, and even choosing what kind of drone to fly, it's not that hard because there's hundreds of vendors that are trying to sell to the US government right now. And talking to them about the ISAC capabilities as something that needs to be investigated as part of drone management. That's not going to be hard to do once you have a use case proposal.
Okay. Yeah, sure. I mean,
I'm working in that space right now because we're looking at alternate power sources, including hydrogen fuel cells. And so that requires having a drone that runs on hydrogen and then being able to control it on local networks. So there's people out there that'll happily accommodate test flights once you know what you're asking for. But you got to be crystal clear on, we're trying to solve this problem. We want your help to go solve it. We have a prototype architecture. The drones are not the problem.
Okay.
I mean, I fly hobby drones all the time, and it's not that hard to fly hobby drones, but that's a hobby drone, and it's not something that is going to be combat worthy. And I'm assuming that people that are trying to defend themselves from deadly weapons are going to pay more than
Yeah.
somebody who wants to run sensor networks in a factory.
No, there is a premium associated. I know, look, the major manufacturers, including Nokia especially, are selling units with some of this capability. So it's definitely an area that there is money, and NVIDIA for certain is looking at this as well. So it is a fundable use case potentially. I think,
And
yeah,
it may
and
be
it can't
not
be it doesn't have to be the only one. Yeah.
NATO is funding this kind of research right now, and
it doesn't have to be the only use case. I mean, we should probably find a couple of 2, 3, 4 use cases that we can take from AI RAN Alliance or the Okudu folks, right? I think maybe we step back and say, okay, what's the first step? Can we put a document together that says, here are the top 5 use cases that we think, this new AI-empowered RU can provide? And we have the principles from the white paper that you guys did, right, not too long ago, to make sure the principles are still valid. And then from there, we can take it forward to say, okay, if this is what we want to do, then can we take the next step in terms of defining this architecture? Because I think, some of those elements in there, the abstraction interfaces, collaboration and all that, none of that changes. We just need to take it to the next step because we haven't yet. And in the meantime, what we haven't done is we locked down the use cases and say, okay, here are a couple of candidate architectures. Do we want to run a process to test them? Do we want to invite vendors to come in and work with us in a few candidate architectures, right? Or do we want to define one? I think that at least moves it forward, right, to something concrete. That would be my thought anyway. So.
In general, as an OCB, that's a good point, Troy. You bring it about the OCB, because the OCB has a stakeholder. Okay, we want to also work with them, like the stakeholder, like the hyperscaler, Microsoft, NVIDIA, Meta, Google, etc., etc. So we want to work. I mean, we want to explore or utilize this connection or stakeholder of the OCB to support the project. If they have an idea, they want to donate it to us, etc. So.
Yep. I mean, look, a lot of the OCP depends on donations or specifications from people with a lot of money, right? I mean, historically, Meta has been the one, right?
Yeah.
But NVIDIA has donated as well, right? So I think, if we suddenly had a, RAN and RU donation from someone, say, share the architecture, here are the pieces, we're going to open it up now, everyone can use it, that'd be great. I'm not sure we have that available. So then the question is, what are the closest candidates to that? And to ascertain what the closest candidates, I think we have to go back and agree on what the definition of the actual operations and the use cases we want to support, at least in round 1 are, and then we can evaluate it. I think because otherwise, without a contribution, without a hardware spec, then we wouldn't succeed, right? So if we said, in 12 months, or I don't know if it's possible by OCP global end of later this year, that we have something, right? It's a milestone. Yeah, how do we achieve that? At least we can move this forward.
Yeah, that's good. Well, that's why extends my point is don't reinvent the wheel, because I mean, the closest partner I see from OCB is NVIDIA, because she has the AI RAN, or it has the AI RAN, it has its also investment in Nokia. And on the other side, we at Lattice, we have been working closely with NVIDIA on that, on the Edge AI case. So that's why I'm saying, okay, we can be creative, or we can go the bus, don't reinvent the wheel. So.
Yep. And if we get NVIDIA, you get Marvell, you get Intel, AMD, and to represent the alternatives, and then maybe you have an architecture that's more open than
Yeah.
fully dominated by a single vendor. Right? I think that'd be ideal if we could get there.
Hey,
Yes.
is Brad here today?
Brad number one is not here today.
Which
Okay.
Brad?
Um, Bell Canada.
Sadly, we only have Brad two.
Okay. The reason I'm asking is in Ottawa at the National Research Council, there's a research lab devoted to 5G, 6G, and integrated sensing and communications, specifically for use cases around drones and AI-enabled
Well, James,
national security.
I would say the main reason I'm okay, but the funding is number one point. Okay, if there is a funding from these, we can spend some effort. If there is no funding,
900 billion Canadian was just approved
okay.
specifically for this use case.
Can you send me that link, please?
Yeah.
Or just post it here in the chat.
And the reason I mentioned them specifically is Canada has an investment and research program going on with Ukrainian drone vendors and is setting up dual factories for for Ukrainian drones in Canada. In particular, one of the most advanced intelligence and surveillance and reconnaissance drones in Ukraine is being manufactured in Ottawa.
Yes, I think there's a Ottawa-based company that was helping them out. I saw something about that a few years ago.
Last year they started construction on the factory. It's a Ukrainian company called Skyaton. And that's being funded by NATO because the Skyaton drone is being adopted both by NATO and by UK for their premier intelligence and surveillance drones. I mean, sorry, premier low-cost surveillance drones. We're talking about something in the, $50 to $100,000 range. Anyway, I put a couple of links in the
So which one is the one that talks about the government?
key site.
The key site one? Okay.
I just found this article, but I'm familiar with the context, the background context. So there may be others more appropriate if you'd search for National Research Council and investment in ISAC.
Thanks.
Here's another one. Let's see. Looks like Rogers is also investing in this area. Anyway.
Yeah. No, thanks. That's good.
I'm sure a day's search with some help from an AI would, help narrow that. Oh, no, I've got a professional subscription to OpenAI. I'll slap it into a private chat window with OpenAI. You can restrict its reuse of your queries if you like. But I can do that and then see what I can come up with. It usually takes about a day to narrow the search parameters good enough with OpenAI to come up with useful answers.
Okay, sounds good.
I don't know if you're familiar with doing research that way, but the newer versions of ChatGPT are giving much higher quality answers.
Yeah, they're all coming. Seems like almost every week there's a new model that does something slightly better than last week's model.
I'm currently using a pro plan, which means I can restrict my queries to my instance and not share it with other users of ChatGPT. And I'm using the currently I'm using 5.2 and putting it in the thinking mode, which gives higher quality answers. I haven't played with the newer version.
Okay. Is there anything else we need to cover today? Did we want to talk a little bit about Canada Tech Day before we
Yeah, we
close?
probably should before we have to split. But we're almost at the top of the hour. What were the dates again? It was 10, 11, June
It was
10th and 11.
the evening is the reception on the 10th, and the 11th is the Tech Day, and it
Yep.
seems to wrap up around 7 p.m.
So it's all afternoon, or is it all day?
It's
Are
all day.
we?
It's all day.
Because I can't remember what the agenda was. Because there is a specific section on on the AI continuum piece.
Yeah, yeah.
So I don't think it's not all day for us. I think there's a couple hour section in the afternoon.
Yep, there
Right.
is. And then there's a panel. Yep.
And in the panel, yeah. So it looks like I'll be able to go for that.
Oh, good. Excellent.
Yep. Yep.
I can find I'll find another hoodie to give you. Actually, I don't
From another one, yeah.
No.
I just wore that Ampere one the other day.
Oh, you did. Excellent.
Freaking cold around here again.
It's in the 60s, 60s,
60s,
70s here.
right?
Yeah, right here. Yeah,
Yeah.
exactly. Yeah.
It should be warmer. But yeah, so that the tech day is those 2 days. So please sign up, folks, if you're
Yeah. Please come see
interested in
Tom.
joining us. Yeah, come see Tom in his new hoodie.
Exactly.
Yeah.
Are you going to be there, Roy? Are you planning
Yeah,
on going?
I'm moderating the panel. I have to be there. Yeah.
Oh, good, cool.
Yeah, I'll be
We'll be
there.
able to
Yes. Yeah,
hang out, get some
yes,
lunch or
looking forward
something.
to it. Yeah.
Cool.
Brad, you gonna be there?
I
Right?
will be there.
No.
Yep. I'll
Good.
be there.
Good thing
And
we got both Brads.
Yep.
Brad number
Brad
one, Brad
one
number
said
two.
he's got to be there too because
He has to
he's
be. It's Canada.
organizing, right?
Yeah. How can he not be there?
Yeah, cool. Looking forward to it. Should be.
I think there's one issue that I would really like to maybe explore with the group
Mhm.
from the ISAC, because there is some optimization challenges here. When we design unified waveform for ISAC for both communication and localization, right? Uh, this is optimize this joint and unified waveform is a mathematically complex problem. And if we rely on AI to do the optimization in real time, that would require models that can handle non-convex mixed, mixed integer programming optimization without uh, introducing lots of latency. So this is really a difficult problem, in my opinion. How to do real-time optimization for both sensing and communication is not an easy problem to solve if we use AI, because this is not a mixed integer optimization problem or even convex problem optimization problem. What do you think about this?
I think it's a very much going to be part of this.
Yeah, I
Yeah,
think I'm thinking about it, and it is not an easy optimization problem that can be solved in real time by AI.
right, right.
But it's something in my mind, and I I don't have a solution, but something I'm thinking about.
Anybody else?
I
No.
fell into the rabbit hole of asking ChatGPT for minimum hardware requirements across transportation, industrial control, and defense, and it gave me a 19-page answer. So,
Wow.
Yeah.
uh,
Well, well,
um,
with that in mind, folks, we're at the top of the hour. We gotta call it. I actually have to jump on another meeting myself.
Yeah,
Um,
likewise.
so we can chat offline on the mailing lists, James, with your findings.
yeah,
Do let us know.
I needed to read what it said. It didn't give me the answer I wanted, which was actually, it did give me a very specific answer on corner cases. So I have to read what it says because this is more than I expected.
Mm.
This is James.
Usually you don't get a
All
coherent
you need is a
answer.
B300, James, and it solves the problem. Just get yourself a B300 and you're good.
Well, it gives me radio configurations by vertical. It gives me duplexing requirements, bandwidth requirements, frequency bands, waveform support, phase coherence, beam forming. It gave me a hell of a lot of things to think about.
Mm.
Um,
Mm.
yeah,
Well,
phase coherent
post
timestamp,
post your
multi-antenna RF.
findings
What's that?
to the mailing
Yep.
list if you can, and then
All right.
we can
So,
take a
Well,
look.
have a good weekend, everyone. Hope to see you
so
all
Yes.
in
I sent
Canada.
Thanks.
I put in the chat a paper that related to this issue about ISAC. You can read it.
Oh, I see that. Yep. No,
Thank you
thanks.
very much. Good meeting. Thank you.
All right. Thanks,
Thank
guys. Have a
you.
good
Thank
weekend.
Bye.
you.
Let
Thank
me
you.
stop
Bye.
the recording here.